All right, so let's do number 6 and 8 now. We're going to cross off number 7. I think it's a little superfluous. So the question is about radiance of convergence. And what I really need to do is go back to the book and read about radius of convergence. Here I am on page 504. Here we go. So the radius of convergence is defined as this number r. Now, we've got 3 possibilities for a series, yes? There's a number such that x minus some constant diverges for more than r, but converges for less than r. And notice that this is an absolute value, yes? So what I'm really saying is this quantity is between negative r and r. So negative r and r would be the diameter. Half of that distance is going to be r. So really it's just the distance from the midpoint to the endpoint of the interval of convergence. Converges everywhere or converges elsewhere. Okay, good. But the radiance of convergence is this number r. So when I look at this problem here, correct? What did I want to do? Well, here, I'm going to go back to where's my Maclaurin table? Here, isn't this my Maclaurin table? Yeah. So this is a series with x minus 3, and it's going to converge. It's of this format. There's the x. When this quantity, the absolute value of this quantity is less than 1, this series converges. Let's take a look. So, I'm sorry. So I've got this quantity, x minus 3, less than 1. Correct? Well, this is just a lot easier than it looks. That's the definition, my friends. That's the definition of r right there. There it is. Right there. X minus 3 less than r. R is the radius of convergence. The radius of convergence in this case is simply 1. That's all it took. Number 8. Let's see, what do we got here? I'm going to rewrite this as, let's see, x minus... Am I looking at the right one? X minus 5 squared. Hold on. Don't go yet. Let's see now. I think I can do this, and then I'll write this as 6 to the 2n. So I've got 2n to the 2n, or I could say x minus 5 over 6 to the n, correct? So if I go back to my x minus a less than r format, what I've got is x minus 5 over 6 is less than 1, and I'll simply multiply both sides, and what I get is x minus 5 is less than 6. So the interval would be 12 wide and would exist at, let's see, 11 and 4, but the radius, no, not 11 and 4, what would that be? 11 and negative 1, and the radius is 6. Okay. Interval of convergence. Wait, this looks awfully familiar. Why don't I write it as, well, it's just going to be the same thing. I'm going to have x minus 6 less than 6, correct? Same process. And then, so let me rewrite. This is going to be greater than negative 1, x minus 6, less than 6, and I just add 6, is that right? Excuse me, negative 6. Plus 6, so I wind up with 0 less than x less than 12. Wow, this is easy. All right, the last problem. Okay, I've got the exact same Maclaurin series here. Yes? So basically, it will converge when that value is less than 1. So all I do is solve absolute ln x less than 1, negative 1, ln x less than 1. Why don't I just raise everything to the e, and I get 1 over e less than x less than e. That is it. I'm going to drop 2 problems off. You'll have an 8-problem test. Do your best, my friends.